Alright, we're going to try and speed things up here a little bit and work through this problem for a second time, a couple variations. I won't take the time for this part of the lecture to work through all the numbers. I think you've seen enough of that. I'm also playing around with this technology of creating these videos for online. You've seen my talking head, ugly talking head in several different orientations. I'm not going to put it on this one, and then we may poll and see which you prefer. I know which one I prefer. It's the one without me in the video. Alright, so the only thing we're changing from our previous problem here is we're going to shoot the cannon up and down rather than just dropping it. Okay, we're also going to make a weight bigger. I did not mention last time, but hopefully you noticed we did not use the weight. The weight does not matter, whether it's 10 tons or 50 tons or 5 pounds. The weight is not going to matter. In reality it does, because it does affect how much air resistance, but since we're ignoring air resistance, we will see that the weight does not matter. That's another important thing to keep in mind. So I'll write that up here. Weight does not matter. Okay? If you ignore air resistance and just deal with the motion. Alright, so we are given this number, and that converted to feet per second, come on, get the right window up here, is 29.33. So we'll let you do that conversion. V1, 29.33 feet per second. Okay, we want to find, let's see, V2 and delta T, just like before. And let's see, we'll use the same scenario. So I'll draw it in really quick. There's my Mini Cooper. Positive is up. Here's our ball, starting from 50 feet. Okay, the difference here is we have an initial velocity, our 29.33 feet per second. Alright, so hopefully you can see that it's going to go up, come back down past our initial height, and then hit it. So if we look at our questions down below, they're actually related to the difference between shooting up and down. So let's work this part of the problem first and then ask those questions. But it's the same exact idea. If we want to find the the final velocity, we'll use the same method as before. Okay, if we don't know the time yet, we can use this equation right there. Okay, so let's see. Just write that out, and then I'll give the solution for it. S2 equals S1 plus V2 squared minus V1 squared over 2A. Okay, S2 is 0, S1 is 50, plus V2 squared, that's what we're trying to find, minus 29.33 squared over 2. And it's important to get the negative sign on the acceleration, otherwise you won't work out right. Alright, so that's going to give us a V2, and we should think through it. We had a V2 from before. If I look back, 56.7 feet per second. It was actually negative. We talked about that. This one is going to give us a value of a larger value, and that's going to be 63.88 feet per second. 63.88 feet per second. We'll let you work through the numbers there. What's happening is it's going up 29.33 feet per second, reaching the top somewhere, so I'll draw it over here. Coming back down, its velocity at that point is actually changed, but would be the same, going downward, and then it hits down here with 63.9 feet per second. Okay. So that's shooting up. Again, the velocity when it hits is going to be down. We can find the time the same way. Okay. If we look back what we did before, we found the time with this equation right here. Whoops, that didn't work too well. We found the equation, the time with this equation right here after knowing the final velocity. So we'll go ahead and do that. So time, let's just go back and look at that, is basically the final velocity. We do have a non-zero initial velocity, so let's just write it out here. V2 equals V1 plus AT, because we need to be careful with our signs. We said V2 is minus 63.88 equals the positive value for our initial velocity, sorry about the scrolling, of 29.33 plus minus 32.2 delta t. Alright, so again, be careful with signs. It's going down at the end. It's got a negative acceleration. It's going up to start with. This gives us a delta t of, go back to my cheat sheet. Let's see, where's that number? Get two well, no you don't. You get one value from that, and it's 2.89 seconds. Okay, that's for going up. All this work is for going up. Okay, let's look at these questions really quickly. Question right there. What changes if we turn the cannon and shoot down rather than up? So let's think about this picture over here in the top right. Okay, now we're going to shoot down rather than up. Do you think it's going to hit with a greater speed, the same speed, or less speed? Okay, before we shot up, went up to the top, came back down, and then hit. Now we're shooting down. And so when I talked about this going up and back down, it's actually going to have the same velocity in the opposite direction as it passes that 50 feet line again. So as far as the velocity down here is concerned, it's going to be the same. Okay, it's going to hit with the same speed. How does the time change if we shoot down rather than up? Well, again, same discussion. We shot up, came all the way back down. Okay, so that takes longer than just shooting downward with that same velocity. It doesn't have to go up and then come back down. So the time is going to be much shorter shooting down. And hopefully you intuitively know that. You do have to stop and think about it a little bit. We can calculate that time that it takes going down from this equation right here. What changes? Well, what changes is we would have a minus 63.88, and our velocity initially is now minus. Alright, so again, being very careful with the signs. Downward initial velocity, downward final velocity, downward acceleration. Alright, I believe that will give us, I'm going to double check here, Looks like 63.88 minus, okay, come on, let's do algebra here. Minus 63.88 plus 29.33 quantity divided by minus 32.2. Probably should have made all those positive and move things around here a little bit. Come on. So quantity minus 63.88. Let's move to the other side. And that should give me 1.07. That's what I wanted to see. 1.07 seconds. And let's off a little bit. There we go. So finishing up 1.07 seconds. This is for going down, or shooting down. This is for shot up. Alright, let's finish that up and get done with this thing.